Hello everyone, let's try to fix this speaker amplifier board from ALTEC Lansing. The model number is IMT7002. Alright, the customer said the device turns on but there is no sound. When I got it at the first, I tested, yeah, I got the screen, turns on, works, but no sound as the customer mentioned. But when I was checking it with the multimeter, I have no display at all. Like for some reason the device completely dead. So let's plug it to the power. You can see the blue light over there. That's the the blue is mean full charge or the battery is not connected. The red is mean charging. And that's the switch is off. So if we turn the switch on, these lights go off, we have no display here. If we turn off the switch, we got the light. Let's take the board and we check it more. So we know that they have no sound problem, but we need to check why the device go completely dead. Now this is a metal. This one it should be, I think it should be 12 volt here. Let's plug it to the power. $15 volt. So the power supply is giving the 15 volt and it's stable. The fuse must be good because we have that blue light. No short. This is a charging diodes, so no short in them. This diode is good. I do remember this one of these ICs, it was like a 5 volt, and even here we can check them. So that's just an antenna, no need for it. This is the DCN. And this is the switch. So let's check if we have 5 volt standby. It's right here. It said 5 volt. So that's the ground. Yeah, we don't have 5 volt. Of course it's not gonna power on if we don't have the standby. I think the standby is made by this one of these ICs here. Okay, let's put this one on the ground. I think this must be 5 volt. No 5 volt here. Check it with the thermal camera. Gonna power it on. I see something here getting warm. This side here, and that's the charging diodes. That's okay. That's normal, the charging diode get warm. And something here could be a capacitor close to this amplifier IC under this heatsink, or could be the amplifier IC itself is bad. So if the amplifier IC is bad, that's explaining why the customer has no sound. Let's check under this heatsink and we check the capacitor under it. Yeah, that's the amplifier IC. Alright, let's see now if it's the IC or the capacitor close to it. There's something right in the edge. Let's go to the under microscope and we see that IC. It's better. So let's turn it on. What about these capacitors? Look at this. You see this? Yeah, you see that is like a heartbeat. You see right here? I don't know, could be the capacitor. Hopefully. Alright, let's check that capacitor. Yep. That's very low. These two pads here and these two pads here, that's for the power, the amplifier power. The voltage is come, but we have a short here as well, and we have short here. Could be the IC is bad. So 0 right there, and that one okay. Yeah. Capacitor, okay. That's shorted. This capacitor test short, this one test short. Now let me remove that capacitor and we see if it's the short is gonna remaining over there. Okay, just stay on the side. Then the capacitor is not shorted, so the short is in the IC. So the IC, yeah, the amplifier IC is bad. So I want to check this capacitor because it's very close to the amplifier. There's a little bit space. Now let's remove this IC and we see the IC mark is right here. Let's use the solder iron to help us remove it. Okay. Alright, do we still have a short in that capacitors? So that's the capacitor was shorted. So no short now. Yeah, no short. It was tested shorted here in power lines. Yeah, no short in the amplifier power lines. From here to here. 0.5 is good. And this capacitor, it was tested shorted as well, is not short. So there is no more short. Alright, let's look at this IC to see what it is. 85 20 90. Alright, let's plug it to the power and see could be the power IC is, the amplifier IC gets more bad. That's why completely the device lost the power. So that's the switch. This is the battery. Oh, that's the DC in. Alright, let's plug it to the power. Blue light. I turn the device, I turn the switch, and the blue lights, it's still on. Yeah, here I turn on the switch. You can see the light is still on, and we have the display. It works. So now we back to the stage 0. That's good. It's mean we get it back to work. Of course, we are going to have no sound because the IC is not there. All right, let's go look at this IC schematic and see where is the input. Yeah, we need the input from the amplifier IC, because so the amplifier section, it doesn't work. The input signal, it works. So if we get that input signal and we give it to another amplifier, we may hear the sound, and that's what we're going to try to check. And to do that, you can use two things. You can use the pen signal trace, or even you can use just a regular speaker with the amplifier and headphone, like a computer speakers. So let me plug this one to the radio, and we turn on the device. So that's a Bluetooth. Okay, let's go to the radio, see if it's gonna scan. Yeah, look like it's it's scanning. If it find any channel, it will stop, I think. Or some of these ones, they will memorize the, so it find this channel 90.5. so right now it's 90.5. yeah, here the volume works. So you can see I can control the volume. So basically this section here, it works. And as we did see before, we have the 5 volt. So here is 5 volt, or close to 5 volt in this coil. We have 5 volt in this coil. This headphone jack is just connected to the regular computer speaker. But first, let's see where is the input. This is AD52060, the same amplifier family. So we have the 2 pins here and 2 pins here for the amplifier power, the VCC, and we have the output right here, and we have the input, should be the right input here, and the left input is right here. So number 3 and 4, or number 11 and 12. Now let's go to the microscope and we're going to see it clearly. So this is the pin number 1, 2, 3 and 4. So 3 and 4, these 2 resistors is for the one of the input, the right or left. And the other input, it must be these 2 here, these 2 capacitors. Here, like if I touch this, the headphone, we can hear the sound in the speaker. Alright, I put the headphone right here. Okay. can hear some sound, right? Okay, now if we connect the ground, so I'm gonna put the ground right here and put the ground anywhere in the device and see if we have a clear sound. So it was from this capacitor.
Season is our top priority.
That's a clear sound.
True.
You see it right here in this capacitor.
24/7 through our outage map and text alerts, and we won't stop work.
So this one, it was connected to the ground, and let me show you. And I put it here next to the USB barrel because that's the ground. All right, and the other probe from here to the input of the IC or the IC place. So that's good. We have a clear sound. Now all we have to do is replacing that IC. Another things, let's check if that IC receiving some power. You see that two big pins or two pins here, this should be, that's the input of the IC, is a 21 volt. The other side 21 volts, so there is a power for the IC. Alright, let's replace that amplifier and should be good to go, right? So yeah, I do have that IC here in stock. So hopefully it's a real IC, it's not a fake one. It's the same IC, the same company. These pins here is just for the power, and both of them is connected to each other. How is the IC? Is it good? Look if there is any short. Yeah, no short. That's good. That's good in the power line. Yeah, the new IC has no short. And alright, first we're gonna power on the device and see if the device is gonna turn on and stay on. That thermal pad, we plug the device. So I power on the device, the blue light is on and the screen is on, so that's a good thing. Next we're gonna plug the speaker. So the speaker is these pins here, and yeah, we need to plug that. We need to connect the capacitor too. Almost I forgot about it, the one that we took. We just solder these two wires for our speaker to test it, because the customer didn't send the speaker to save in the shipping. Speakers are heavy, and if we make it work with our speaker here, it's gonna work with any speaker. Alright. voltage. So now is speaker right here. Now the moment of the truth. Let's plug it to the power. Okay, it turns on. C04 CFM radio. But we have no sound. So yeah, so everything works, but we have no sound. The IC is not shorted. So let's go look at the Chrome. So that's the IC52. This is the same family as our IC. So this side is everything looks good here. We have the voltage input, nothing like major. There's not a lot to check here because this is just the output speakers. 2 output speaker, voltage, and that's it. And the other side as well, we have the 2 inputs that we test them, and we have the sound. The only 2 things that's 2 pins that's very important in these 2, the SD and fault. This SD is an on-off switch, or sometimes it's called mute. And you can see this is SD is a shutdown signal, so it means on-off button for the IC, and when it's low, is disabled. When it's high, the chip should be in the on mode or operational. And the same thing is fault. This is made to detect any high voltage or something wrong with the input voltage. But here we need to be high, so we need some voltage in this pin for the IC to work. Let's go check in the IC. Okay, the pin number 1 and pin number 2. So we have, that's the ground. So we should have some voltage over here for the chip to work. And these 2 pins, the SD and the fault pin, they need, both of them, they need the voltage. And you can see them is connected to this resistor. So no voltage the other side of resistor. Okay, we have a transistor here. So we have no voltage in this transistor as well. Yeah, I'm trying to check all the resistor that's going to these pins. So if we find the voltage one side and not the other side, it means the resistor is bad. Or if we find the voltage in one side of transistor but it's not going to the other side, it means the transistor is bad. I don't see no voltage right here. Yeah, all this, it has no voltage. Alright, we can give it voltage. Let's set up this one at the diode. You know, when we check with the multimeter, we use the multimeter with the diode mode. We are sending a small voltage to the probes. Okay, I'm going to send a little voltage to that pin and see if it's going to work. So this one here, and that's the red probe. Let's give the voltage to here. It works. Did you hear it? Yes. So like we are enabling the IC. Yeah, it works. We fix it. We find, basically we find the problem. So we can blame none of these components as there is no voltage inputs. And you can see if we follow the traces, it's going to this IC. Could be this IC is now giving the voltage to down. This is a programmed IC. The solution here, we are gonna need to give this pin some voltage. And let's check where we can get that voltage from. So we can use that voltage to enable the IC from the 5 volt standby. So this is the 5 volt standby, this pin here. You can see it is a 4.5. And that pin is from here, it's go to the capacitor, then go to this resistor. So yeah, we can get the voltage from that resistor. I'm gonna solder a wire right here. And we solder the wire to the 5 volt. Fix that resistor because it's moved. We can solder it from here. Right there. So we solder the enable pin to the 5 volt. Here is enable pin going all the way to the 5 volt. Alright, let's test it. See if we got any sound. Yeah, I hear the speaker.
Welcome to ALTEC Lansing.
You hear that? It works. Yep, the volume works. Alright, it's fixed. So this all for this video, and see you again.